BIDMAS, or sometimes referred to as BODMAS, is the order in which you do the operations. The B stands for brackets, I is indices, which are the powers, like squares and cubes. D is division, M is multiplication, A is addition, and S is subtraction. The division and multiplication are actually linked together. If you only have division and multiplication, you do them in the order they appear, left to right. It's the same with addition and subtraction. Let's have a look at example 1. Example 1, we've got an addition and a multiplication. According to BIDMAS, the multiplication we need to do first. If it helps, add in your own brackets. So what we're going to do is the multiplication first. So we're going to work this out. 3 times 4 is 12. And then what we're going to do is 5 plus the 12. When you work that out, you get 17. In example 2, we're going to do the brackets first. So we're going to work out 4 plus 3 first, which gives us 7. Keep everything else the same. Thinking about BIDMAS, the next thing is indices. So we're going to look at the indices next. We're going to do 7 squared and get 49. And then finally, we're going to work out 10 times 49, which gives us 490. They could put a twist on the question. In this question, we need to put brackets in to make the question correct. As it stands, if you were to apply BIDMAS to this, you'd do 8 times 7 first and get 56. You would then do 7 take 56 and get minus 49, and then minus 5 from it, and you get minus 54, which does not equal minus 9. What the question is asking us to do is put brackets in there so that it does equal minus 9. If we were to put brackets here, then BIDMAS would say do the brackets first. So we'd work out 7 minus 5 first and get 2. BIDMAS would then say you do the multiplication first to give us 16. And 7 minus 16 does equal minus 9, which is correct. So the brackets have to go here. When working with negative numbers, a rule we can use is if 2 signs are the same, it's a plus. And if 2 signs are different, it's a minus. So here, because 2 signs are the same, the minus and minus become a plus. We get minus 1 plus 4, giving positive 3. In the second example, the 2 signs are different, so they become a minus, and we get minus 8, minus another 6, and we end up at minus 14. When multiplying or dividing with negative numbers, it's a good idea to decide on the sign first, and then do the calculation. In this question, we've got minus 6 times minus 1. Let's work out the sign first. A minus and a minus become a plus, and then the calculation, a 6 times 1 is 6. So our answer is positive 6. We don't really need the plus sign. In the second example, we've got minus 12 divided by 3. Let's decide what the sign is first. You've got a negative divided by a positive. The signs are different, which means it must be a minus. So a negative divided by a positive is a minus. And then do the calculation. 12 divided by 3 is 4. In example 3, let's have a look at the signs first. Here, the two signs are the same, so it becomes a plus. Here, the two signs are different, so it becomes a minus. These are also different, so that becomes a minus 2. The question now becomes minus 1 plus 2, minus 3, minus 4. And when you work this out, you get minus 1 plus 2 is positive 1. Take 3 from it, you end up at minus 2. And then take another 4 from it, you end up at minus 6. We're going to look at the different types of numbers. These are just a few examples. The first type of number we're going to look at are square numbers. A square number is anything multiplied by itself. The first square number will be 1 times 1, which gives us an answer of 1. And then 2 times 2, which gives us an answer of 4. The next one will be 3 times 3, and 3 times 3 is 9. The next one is 4 times 4, which is 16, 5 times 5, which is 25, 6 times 6 is 36, 7 times 7, 8 times 8, 9 times 9, and 10 times 10 is 100. 11 times 11 is 121, and 12 times 12 is 144. You could carry on going if you wanted to. A cube number extends this. This time it's the same number multiplied by itself 3 times. So 1 times 1 times 1 is 1. As it says here in the example, 2 times 2 times 2 is 8. 3 times 3 is 9, and then times it by 3 again, you get 27. 4 times 4 is 16, times it by 4 again, you get 64. 5 times 5 is 25, times 5 again is 125. This missing number here, we're going to do 6 times 6, which is 36, and times it by 6 again to get 216. That's 7 cubed, 8 cubed, 9 cubed, and 10 cubed. Another way of writing this is with a small 3. Just like when we do a squared, we put a small 2. Another type of number are triangle numbers. These are how many dots you need to make the triangle. What we're going to do is add on another line each time. So here we start with 1, then we added on another 2, then on the next line we added on another 3. And then on the next line we added on 4 more. And then on the next line you could add 5, and then 6, add 7, 8, 9, and 10. Odd numbers are anything ending in a 1, 3, 5, 7, or 9. Doesn't matter how big the number is, you just need to look at the last number. And if that ends in a 1, 3, 5, 7, or 9, it's odd. Same with even numbers, but this time it ends in a 0, 2, 4, 6, or 8. Multiples are anything in the multiplication table. For example, multiples of 5 are its 5 times tables. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and so on. Factors are the other way around. These are numbers that go into another number. For example, 12. You want to think of numbers that divide into it exactly. So we have the number 1 that goes in, 2 that goes in 6 times, 3 goes into 12 4 times, which is another factor, and that's it. Prime numbers are those which will have only 2 factors, which are 1 and itself. The first prime number is 2. This is the only even prime number. The next one is 3, and then 5, and then 7. 9 is not a prime number, because for 9, the factors of 9 are 1, 3, and 9. That's 3 factors, so that's not a prime number. The next one would be 11, and then 13, and so on. Highest common factor is exactly that. You look at the factors of the numbers. You then see which they have in common, and then you pick the highest one. As we said earlier, factors are numbers that divide exactly into another. We're going to look at the factors of 36. Possibly the best way of looking at factors is this. Just start with 1. 1 goes into 36 times, so I know 1 is a factor and 36 is a factor. Then I look at the next number, 2. 2 goes into 36 18 times. Then I'm going to try 3. That goes into 36 12 times. Then I'm going to try 4. That goes into 36 9 times. 5 doesn't go into 36. 6 goes into 36 6 times. And because I've reached that number there, I can stop. In fact, I don't need the 6 twice. So these are the factors of 36. If I do the same with 20, 1 goes into 20 times. 2 goes into 20 10 times. 3 doesn't go into 20. 4 goes into 20 5 times. And I don't need to try 5 because that's already there. So these are all the factors of 20. The next stage is to see which factors they have in common. 1, 2, 4, and that's it. So the highest common factor of 36 and 20 is 4. Lowest common multiple is very similar, but the opposite way around. This time we're going to look at the multiples of all the numbers. We're then going to see what they have in common and find the lowest one. So the multiples are the multiplication table. So the multiples of 6, 12, 18, 24, and so on. The multiples of 9 are 9, 18, 27, and so on. But I don't need to carry on because I've found the common multiples of 6 and 9. They have 18 in common, 36 in common, and if I carried on going, I'd get more. But we're interested in the lowest common multiple, and the lowest common multiple is 18. For big numbers, we need a different way of doing highest common factor and lowest common multiple because the list would be too long. This involves using prime decomposition, which can be a question on its own. To work out the prime decomposition of a number, you keep splitting it until all the numbers that are left are primes. What we're looking for are two numbers that multiply to give 96, and it doesn't matter which two you use. Because I know it ends in a 6, which is even, I know it's divisible by 2. So 2 times 48 gives 96. If you end up with a prime number, you can circle it, so 2 is my prime number. 48 is not a prime number, so I need to keep breaking that down into prime numbers. I need to think of any two numbers that times to give 48. I'm going to go with 6 and 8. Neither of these are prime numbers, so I'm not going to circle them, but I'm going to break them down further. 6 is the same as 2 times 3. Both of these numbers are primes, so I can circle them. 8 is the same as 2 times 4. 2 is a prime, 4 is not. I'm going to break this down further into 2 times 2. What I end up with are the circle numbers as its prime decomposition. The circle numbers are 2, 2, 2, 2, 2, and a 3, which means 96 is the same as 2 times 2 times 2 times 2 times 2 times 3. It doesn't matter which two numbers you use as long as you keep going further until you get down to the primes. For example, instead of choosing 2 and 48, if I chose a different starting number, I will still get the same answer. Let's say instead I went for 6 and 16. But then break this down into 2 and 3. 16 is the same as 4 times 4. These 4s I can break down into primes as 2 times 2. And if you look, I've got 2 times 2 times 2 times 2 times 2 times 3, the same answer. Doing the same with 180, I'm going to break this down. I can see it's divisible by 10 because it ends in a 0, so I'm going to say that's the same as 18 times 10. I know 2 times 9 makes 18. I could have chose 3 times 6. 2 is a prime, so I'll circle it. 9 is not a prime. I can break that down into 3 times 3, which both are prime. 10 is the same as 2 times 5, both of which are prime numbers. This tells me 180 is the same as 2 times 2 times 3 times 3 times 5. From earlier, we saw 96 is the same as 2 times 2 times 2 times 2 times 2 times 3, and 180 is the same as 2 times 2 times 3 times 3 times 5. We're now going to use a Venn diagram to find the highest common factor and lowest common multiple of these two numbers. Anything that is shared by these two we put in the middle here. So for example, they both have a 2. So I can put a 2 in the middle. There is also another 2 they both share. This has some more 2's, but this doesn't, so I can't share them. They do both, however, have a 3. They have nothing else that they both share. The 96 is left with a 2, another 2, and another 2, so I put that into the 96 bit. 2, a 2, and another 2. The 180 was left with a 3 and a 5, so I put that into the 180 bit only. To work out the highest common factor of 96 and 180, you look in the middle. If you multiply these numbers together, so the 2, and the 3, we get 12. That's the highest common factor of 96 and 180. If you want to work out the lowest common multiple, we look at all the numbers in here, including those in the middle. So we're going to do 2 times 2 times 2 times 2 times 2 times 3 times 3 times 5. Which gives us an answer of 1,440.